This is Brian Pace with Actifio. Today we want to take a brief look at Oracle's block change tracking. So let's get started. First, let's talk about some quick facts. Feel free to use this slide as a quick reference, just as a reminder. But high level, block change tracking information is stored in an external file called a block change tracking file in Oracle. There's some $$ views, which we'll use later in the presentation, that exposes metadata from the block change tracking file. This can be useful, and you see how we use it when we dig into the details. There's a background process, change tracking writer, a little bit tongue twister to say, that maintains this file. And we're going to take a look at when it does it, how it does it, later on in the presentation. Important thing to note is that blocks are tracked in chunks. In other words, there's not a bit in the bitmap for every block that exists. Instead, the changes are tracked in chunks, in 32K chunks by default. That's important when you think about very, very large data files. If you had a bit for every block, that would keep the change tracking writer pretty busy. Tracking is modified. The bits are flipped as those chunks, or a block in those chunks, are changed, and we'll get to see how that works at a logical view. A set of bitmaps that form a bitmap version, and there's up to 8 versions by default for every data file. And each incremental backup creates a new bitmap version. Sounds a little confusing, but let's take a look at the details, and I think it will become clear. So what I have here on the screen is, on the left side, I have a representation of a very small data file. So it's very clear how things are working here. It's just a 40 block data file. That data file in the block change tracking file is going to have 8 bitmap extents, where it will maintain those 8 versions that we talked about. Now, every time an RMAN backup occurs, a new version is created. So let's dig in a little bit and just see what's taking place here. So on the screen, think of this, if I can equate it to redo logs for a moment. There are 8 extents out there that are used in a circular fashion, almost like your redo logs, right? The redo logs are used in a round robin type fashion. Once one is full, it advances to the next redo log, assigns a sequence number to the changes that's going to go in that redo log. That's what's happening here, except instead of logs, we're talking about bitmap extents inside of the block change tracking file. So there's 8 extents are reused, and what causes a new extent to be reused is an incremental backup from RMAN. So an example on the screen, you see the latest version is the dark blue version 11. So version 11 was created during the last incremental backup. When the next backup runs, version 12 would be created. So in this example, the version, the bitmap extent that's represented by version 4 will be overwritten, and that will become version 12, and the cycle will continue. Just reusing these 8 versions. Now you can increase that, and we'll talk about when to increase that later on. In this example, the last backup occurred, created version 11. And as you see, there's 2 bits in our bitmap that have been flipped to 1. Now what those represent, if we look back at our data file here, those first 4 blocks, that represents a 32K chunk. Remember that we're not tracking in the block change tracking file at the individual block level, but for efficiency, we're tracking at the segment level, and that segment is 32K chunks. So here we see that first 4 blocks, which makes up our 32K, has 2 blocks that have changed in it. Therefore, the first bit in our bitmap has been flipped to 1, and that would tell RMAN that, hey, in this first 32K chunk, there's at least 1 block that has changed. In the next set of 4 blocks, the next line down, there's no blocks that have been changed. So that bit, if we look over in our bitmap, is still 0. And then in the third row, our next set of 32K bytes, if you will, or 32K chunk here, 1 block has been modified. Therefore, the bitmap on our third bit here, and our bitmap has been switched to 1. So that's what's taking place in the background. Now, when RMAN runs, so when the next backup runs and version 12 is created, assuming it's just doing a differential incremental backup, it's going to look back at version 11 and it's going to say, okay, bit 1 is flipped to 1, so I'm going to read 32K, the first 32K in the file. The next 32K I'm going to skip because nothing has changed. And then I'm going to read the third set of 32K. And once I get that data, I'm going to look at the blocks inside of each of those chunks. And it does this as it reads each chunk, determine exactly what block was changed and write that block out. Hope that helps with especially with the comparison to redo, because these versions are going to come into play. And let me show you what happens and why the versions are important to understand. So here we see an RMAN cumulative backup. Now, a cumulative incremental backup methodology basically says for each level 1 incremental, I'm going to back up all the changes since the last full. Now, that's very important when it comes to restore time. So I don't have, if I had to restore on Friday, then I would just have one incremental to apply, and that would be the last cumulative. Whereas if you're doing a differential, I'd have to apply the incrementals from each day. That's the power of Actifio. The way we do backups is that every day you have a virtual full copy, but we can talk about that later. So in this example, on Sunday, January the 5th, a level 0 was performed and version 10 of the bitmap was created. Monday night, or Monday morning, I should say, a level 1 was done, and we created version 11 of the bitmap. And when that incremental ran, it used the bitmap created from the level 0, which was version 10, to find out what blocks has changed since that level 0 occurred. On Tuesday, the 7th, our next incremental level 1 executed. It created version 12, and then it used the bitmap from version 11, and it used version 10's bitmap. So it knew what blocks it needed to go read to get back to the level 0. And that process continues Wednesday, Thursday, Friday, same story. Since they're cumulative, they're using all the bitmaps from the prior level 1s until we get to Monday. And then Monday, the 13th, something interesting happens. We create version 18 of the bitmap as soon as that backup begins. But version 18 needs a slot or a bitmap extent to use. Remember, there's only 8 by default, and this is going to be my 9th one. So what happens? Well, I'm going to go back to the oldest bitmap, and I'm going to reuse that bitmap extent. In this case, I'm going to reuse the extent that the level 0 from Sunday created. So I'm going to overwrite version 10. But now it's time for me to go read data. There's not enough bitmaps available to me to get all the way back to the level 0 because I just overwrote the version 10. So I have to do a low splash read. I have to read every block in the database in order to get my cumulative backup. So what could we do here? Well, we could add a level 0 in on the 12th. We could increase the number of bitmap versions. If I had increased it from 8 to 9, I would be okay. I would have got in trouble on Tuesday, but you can see how I could increase the number of versions to help. So let's apply this even further. This is what most of you are doing. You're doing an incremental differential every day. You do your level 0 on Sunday, and then Monday through Saturday it's a level 1, and each of those level 1s just capture the data since the last level 1. In the context of bitmap versions and block tracking, there's no issue here. We could set the bitmap version to 2 or 3, even smaller than the default, and we would be okay because each level 1 is only reading back to the previous level 1. So at most, it's only reading one version of the bitmap. But what happens if I have multiple backup methodologies in play, or I'm using a traditional backup and I'm using Actifio for test data management? So let's take a look at how that impacts the blockchain tracking. So here you see, we still have our incremental backup going on in the background, but now we've got Actifio coming into play, and Actifio is ingesting the data at certain periods of time. So on Sunday afternoon, on the 5th, we do our initial ingest. This is a full copy of the database, an RMAN image copy that we ingest. Now, when we do that, we create version 11. Because at the end of that full ingest, we are going to do an incremental merge because we're assuming it took a while to do that initial ingest. Monday, Tuesday, Wednesday, the incrementals are happening just as normal. And then Wednesday afternoon, we decide we want to do another snapshot. We want to update our snapshot. So we're going to present uh, our disk back to the database, and we're going to tell RMAN, hey, do an incremental merge on this full copy of the database and roll it forward. Well, RMAN is going to look at our copy, and it's going to say, oh, this was made as of SCN XYZ. That was on Sunday. So it's going to go back to version 11 of the bitmap, and it's going to use version 11, 12, 13, and 14 to figure out what blocks it needs to read. So it only reads the changed blocks, and it's going to do the incremental merge, and then we'll snap that internally and have a virtual full copy as of Wednesday afternoon. Then we're going along fine, incremental, 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 incremental. Friday afternoon on the 17th, we want to do another snapshot. We're going to present this logical full copy of the database back to the server, and we're going to tell RMAN, you need to update this to today. RMAN is going to look at the data files. It's going to determine that it needs to go all the way back and get all the changes since Wednesday afternoon on the 8th and roll those forward. But here's the problem. Because we have done more than 8 incrementals since our last snapshot, there's not enough bitmap versions available for me to use blockchain tracking. So now I have to do a low splash. I have to go read the entire, or RMAN has to go read the entire database or data files to figure out what blocks have changed. So you can see here why it's important to understand the versions and how they work. Now what we could do in this case is Actifio is incremental forever, and the space to do incrementals throughout throughout the week is very, very low impact. So we could have increased the times we do snapshots. We could have just added more bitmap versions. So we could have maintained 12 bitmaps, and that way when we did our snapshot on the Friday afternoon on the 17th, there would have been enough versions in the bitmap extent to only read the changed blocks. So let's take a closer look. We're going to do 2 scenarios. One is a normal Actifio and second-party integration. So maybe you're just using kind of like the timeline that we just left. You're only using Actifio for a TDM, and you're still using some other tool to do just your normal backups. And then the second scenario we want to look at is the last part of that timeline where all 8 versions have been exhausted, and what you can look at to determine what has changed, what hasn't changed. Scenario 1, we do our level 0 backup. That was done on January 23rd. You see the record ID of 1838. RMAN read 21,824 blocks. You see the incremental level there was 0. So there's about half the blocks, half the data file is used. And then we created version 112. So as we look at the $X view at the change block bitmap headers there, we see that in the in that last bitmap extent that's available, we created version 112. So now we do our level 1. Now, since our last level 0, I updated about 38 blocks, distinct blocks. And what we see here is record ID 1847. That is indeed our level 1 backup. And it only read 45 blocks. Now, why did it do that? It did that because it went back to the bitmap version 112, which was the one generated by the previous incremental backup. And it used that bitmap extent to determine what chunks of data it needed to read. And you notice it read more blocks than it written. But remember, it's got to read that whole 32K chunk, and it's only going to write out the blocks within those chunks that have changed. In this case, I'd updated 38 blocks. The other block is obviously the file header. Now, as we look at the $X view, you can see I generated version 113. How we do our Actifio ingest. Our Actifio ingest generates version 114. Now, we're doing an RMAN image copy on our initial ingest, and we do perform that last incremental backup, assuming that the initial image copy took some time. And that initial, that incremental merge that we do at the end of our initial copy is what actually advanced the version count to 114. But the important thing to note here is I'd updated 39 blocks. I did my Actifio initial ingest. I created version 114. And then after I did my ingest, I updated those same or different 38 blocks again. So now we do the level 1. Now the level 1 comes in, and you see 1859 has been created. I read 85 blocks. Now remember, I'm doing about 38 blocks each time. So that's 76 blocks that actually changed. I read 85 because I'm reading in 32K chunks, remember? So what this is telling me is that even though I did this snapshot with Actifio in between 1847 and 1859, that RMAN knows he needs to go back to that backup done on 1847 and get all the blocks that have changed since then. Now, he didn't do a low splash. He only read 85 blocks, which means he leveraged the Bitmap version 114, which was created during the Actifio snap, and it used version 113, which was created during the last incremental level 1, thus getting us to the 85 blocks. So let's look at the next scenario. In this scenario, the last incremental that we did created version 65. Now I'm going to go through Actifio and I'm going to do 8 snapshots. And that's going to roll the versions forward. Each of those snapshots is going to consume a version. So I generated 66 through 73, as you can see there on the bottom. What that means is version 65 has been overwritten. So what happens now if I kick off a level 1 backup? Because that level 1 backup has got to go back to version 65. Well, let's take a look. So here's my level 1 backup. Notice what happened. I read the entire data file, all 40,000 blocks. Because I exhausted the block change tracking, it had to read every block in the data file. If you have any questions or want to go into more detail, feel free to reach out. I appreciate your time today and look forward to talking to you again soon. Take care now.